Hello everyone and welcome to IB Mathlogy, your space for mastering IBTP mathematics. Today we'll be learning the complete explanation of differential equations. So let's start from the beginning. Basically, a differential equation is any equation that contains a derivative. Derivative means either I can write y dash or I can write dy by dx. So if you ever see dy by dx, or I can also write d2y by dx square, something like this, anywhere in the equation, it means it is a differential equation. So let's take some example how a differential equation looks like. So I can write dy by dx is equals to 2x. So this is a differential equation. Another example, I can write y double dash plus y is equals to 0. So this y double dash is basically d2y by dx square. Another example, y dash plus let's say 3y is equals to x square. Yes, this 2 is a differential equation because it has y dash in it. Now, why do we need them? Because the real world gives us rate of change. So this rate of change, whenever it comes into the picture, we are talking about differential equations. Now there is a term known as order and degree, which is very important to learn before getting into the solution of any differential equation. So basically, if we talk about order is the order of highest derivative present. This is very important, so you should note it down. Highest derivative present. So the order of a differential equation is the order of the highest derivative present. For example, if I write y dash is equals to 2x, so its order is basically 1. Why 1? Because my y dash, that is dy by dx, has the power 1. Now, if I take another example like y double dash plus 3y dash plus y is equals to 0. So this will be having order 2. Now why order 2? Because I am talking about y double dash. Now if I write it like this will make more sense. So if I write it in dy by dx form, I will get my equation like this. Now the highest derivative given to me is the double derivative. That is why the order is 2. Now let's take another example for order 3. So for order 3, I can write d3y by dx cube. You can write equals x plus y. So it has order 3 because I have this differential equation where dy by dx has the maximum power, highest is 3. Now the next thing that comes is degree. Once you understood order, then it is easy for us to understand degree. So the degree is the power of highest order derivative, but only when the equation is in polynomial form. Degree does not exist for square roots, fraction with derivatives. Now if I take an example, let's say I am writing dy by dx whole cube plus 2y is equals to x. Now I have dy by dx in the equation. It means it is a differential equation and the maximum power is 3. So my degree will be 3. Now if I take another example like d2y by dx square plus dy by dx is equals to y. Now the degree should be 1. Why the degree should be 1? Because my highest order derivative is d2y by dx square and its power is 1. That's why the degree is 1. Now what is important to note is whenever you have something like this, under root dy by dx, or let's say sine dy by dx, like this inside any trigonometric function, so for all this the degree is not defined. So you have to remember it. This trips us so many students in exam, so you should remember this. Now let's understand how to find the solutions of any equation, any differential equation. So there are two types of solution. One is the general solution and another one is particular solution. Now general solution will always be in C form. We will write a constant as C, and for particular solution there will be some conditions given to us from where we can find this C value. Now for example, if I say solve dy by dx equals to 2x. Now how will you solve? First we have to remove dy by dx, so I will integrate both sides with respect to x. Now integration is basically anti-differentiation, so I will get y over here and here I will get x square. Now since no condition is given and we are integrating, so we have to add this c, so this becomes my general solution. Now if we talk about particular solution for the same question, so the question will be like solve dy by dx is equals to 2x, solve when x is equals to 0 and y is equals to 5. So again on integrating we will get y is equals to x square plus c. Now we will use this condition. I will put y as 5, x as 0. So I will get my c as 5. So my solution will be x square plus 5. So this becomes a particular solution because this condition is given. So this is a particular case apart from the general solution. Now let's take another example where we have to find the particular solution to the differential equation y dash is equals to sine square x, and what is given to me is y0 is equals to half. So let's understand how to solve this. First of all, what is given to me is dy by dx is equals to sine square x. Now we have to integrate both sides. Upon integration, I cannot directly integrate sine square x. So left side I will get y. For right side I have to use double angle identity. Using double angle identity I will get this. You can see cos 2x identity. From your formula booklet, you will see this. Now I can easily integrate. So first one will become x by 2 and the second one will become cos integration is sine 2x plus c. Now what is given to me is y0 equals to half. It means my x is 0, so my y value is half. So I will substitute. It will be 0 by 2 minus 1 by 4 sine 0 plus c. So sine 0 is 0, so my c value becomes half. So I can say that its solution is y is equals to x by 2 minus 1 by 4 sine 2x plus 1 by 2. So this becomes my particular solution. Now you can try this question. Dy by dx plus 1 is equals to cos x. Solve this question and put your answer in the comment box. Now let's understand another form of the differential equation, that is separable differential equation. So whenever you have any differential equation of the form dy by dx is equals to some function of x multiplied by some function of y. So this is separable differential equation. For example, I can write dy by dx equals to x into y. So how you will solve this? We will first separate the variables. So when I will separate the variable, I can write 1 upon y dy by dx is equals to x. So from this I will write this. Now I can integrate both sides. So I will get 1 upon y dy by dx. I am integrating with respect to x. So I'll get this. Now if you further solve this, I will get 1 upon y dy is equals to integration x dx. Now 1 upon y integration is ln mod y and x integration is x square by 2 plus c. Now you can leave your answer in this form, but what examiner wants is the simplified form in the form y is equals to something. So since I am removing ln, so I can write it as plus minus e to the power x square by 2 plus c. So that becomes my answer. Now let's take another question. We have to solve the differential equation dy by dx is equals to e to the power 2y cos 3x, and what is given to me is y0 is equals to 0. Now first of all we have function of y, function of x. So I will bring this e to the power 2y to the other side. So it will become like this. Now I can integrate both sides with respect to x. I will get this. So I can write it as e to the power minus 2y. It becomes dy and this remains as it is, cos 3x dx. Now e to the power minus 2y integration is e to the power minus 2y whole divided by minus 2. Cos integration is sine, so cos 3x will be sine 3x upon 3 because we have to take out the derivative of 3x plus c. Now again we can simplify this and we can write minus 2 by 3 sine 3x plus c, and we can take ln on both sides because I want my solution in the form y. So it will be ln minus 2 by 3 sine 3x plus c. Now I will use this condition that is being given to me. It means when my x is equals to 0, my y value is 0. So I will put 0 is equals to ln 0 plus c. It means I am getting ln c as 0. It means my c value is 1. So the particular solution will be y is equals to, I can take this minus 2 to the right side and I can write minus 1 by 2 ln minus 2 by 3 sine 3x plus 1. So this becomes my particular solution for this particular differential equation. Now you can try this question and put your answer in the comment box. 3x upon cos y, and what is given to me is y1 is equals to 0. It means you have to find the particular solution for this given differential equation. Now another very important form is homogeneous differential equation. So whenever you have a form like this, dy by dx as function of y upon x, where you cannot separate the variables. So this is your homogeneous differential equation. And the trick to solve this is, we will always assume y is equals to vx and then we will solve. So let's take an example. So we can say that the question is, show that dy by dx is equals to x plus 2y upon x is homogeneous. Now how will you show? So to show this, what we can do is, dy by dx is equals to, we can separate the denominator and I can write it like this. So this becomes dy by dx as 1 plus 2y by x. Now my equation is in this form where I have a function of y over x. Now how to solve this? So let's understand. We will assume y is equals to vx. Now when we are assuming y is equals to vx, we have to take derivative both sides. So I will apply product rule. So I will get v plus x dv over dx. Now I will substitute this value over here and y is equals to vx over here. So comparing with the differential equation, I can write x dv over dx is equals to 1 plus 2v. Now we just need to simplify this. Now how we'll simplify? So I can write x dv over dx. This becomes 1 plus v. You can bring this v to the other side, so it becomes v. Now just separate the variables. Now this becomes variable separable form. Now to separate the variables, I can write it like this. Now we have separated the variables, so we can integrate both sides. So left side integration will be ln v plus 1 and right side integration will be ln mod x plus. Now you can write c or you can write ln c. It's one in the same thing. Now we can solve this and I can write it as mod xc, x into c. So on comparing both sides, I will get v plus 1 as x into c. Now we have, my question was in y and x, so I cannot have this v. So v was y over x, so I can write y over x plus 1 is equals to x into c. Now if any condition is given to me, I can find c. So this becomes my general solution. So I can write my general solution as xc minus 1 into x. So this becomes my general solution. Now if any x or y condition is given to me, so I can find out the particular solution also. Now another very important method is integrating factor method. You will definitely get a question from this method. So if you have any differential equation of the form dy by dx plus something p, that is a function of x, into y is equals to q into x. So this type of equation we can solve only using integrating factor method. Now you cannot separate any variable from this. So the integrating factor will be I of x. I will be using I of x for integrating factor. Now what exactly is this integrating factor? We have to first make our question in this form and then we have to pay focus on this px. So my integrating factor is nothing but integration e to the power p dx. So your first step is to make your question in this form. Second most important step is to find the integrating factor, and the third most important and the last one is multiply my first step or my question with integrating factor, and then it will be easy for you to solve. you can find the general solution. Now let's take an example. If I am saying solve the differential equation dy by dx plus, let's say, 3x square y is equals to 6x square. Now you cannot separate this x square y, so we have to use integrating factor method. Now if you compare with this, so this becomes my px and this becomes my qx. Once you have identified what is px and qx, then it's very easy. So we are done with step 1. Now my second step is you have to integrate. So integration 3x square dx. So this becomes, if you integrate, you will get x cube by 3 and 3 will get cancelled out. I got my integrating factor as e to the power x cube. Now I am done with the second step. Now the third step is multiplying both sides of the differential equation by this integrating factor. So I will write e to the power x cube y, I am writing dy by dx as y dash plus 3x square y is equals to 6x square multiplied by e to the power x cube. So this becomes my done. I am done with the third step. Now you always have to pay attention to the left side. So if you remember u into v dy by dx of any u into v, so we will apply product rule and we will get u into v dash plus v into u dash. So we will always get this form after step 3. So if you see, if I assume e to the power x cube as u and y as v, so u v dash plus this becomes my u dash, this becomes my v. So this is one of the most important form. So this is my u and this is my v. So I have v dash and this is my u dash. Please understand this step very carefully, very important form. So I can write my left side as d by dx of u into v. Now most of the students remember it like this. After third step, this step will always be d by dx of your integrating factor multiplied by y. So you can remember it anyways, but it's good if you remember it using this step. Now we have to integrate, so we can simply write, if we are integrating both sides, so I can write it as e to the power x cube into y. Now you have to integrate this. Now how will you integrate? I can write this as integration 6x square ex cube into dx. Now again you have to use methods of integration. So you can assume, let's say, x cube as t. So 3x square dx will become dt. Now once we have assumed, so integration 6x square e to the power t, my dx will become dt over 3x square. So it will become, this 2 will get cancelled out. So 2 integration of e to the power t is e to the power t only plus c. So what I can write is e to the power x cube into y is equals to 2 e to the power x cube plus c. It means my y is nothing but 2 plus c into e minus e to the power minus x cube. So this becomes my solution of the given differential equation. I am giving you one question. You can solve it and drop your answer in the comment box. D minus 3y is equals to e to the power x. So you have to solve it using integrating factor method, and to find c, the condition given to you is y0 is equals to 2. So that's all for this video. In my next video, I will be solving some past year IB papers, questions based on differential equation. So stay tuned. Until then, keep learning, keep growing, and remember, every hard topic was once unfamiliar. You have got this.